As you can see on your screen, I'm sharing some screen there. As you can see, paper 2 consists of the 6 main areas. Number 1 area, which is constituting graphs. So as a very serious student, you can choose to say that I want to discuss graphs alone in all the topical areas that are there for graphs. So you can choose to do the graphs in 1 day or 2 days. That will be 1 area out of the 6. Of course, I've said that the 25 topics, I have synchronized them into 6 main areas. The main reason for this is for ease of revision, especially now that you're a candidate, or those who are pre-candidates. It will be easy for you to do your revision considering this. We will talk about the graphs. After talking about graphs, we will be talking about commercial arithmetic and related areas. After that, we are going to be talking about geometry. Geometry consists of some topics that we will see. Then we have an area which I have called specialized topical areas. Specialized topical areas, I will give you the topics that are based under this. Then we have calculus and area estimation, which is part of the paper 2. I'm aware the speaker on paper 1 told you something about calculus in paper 1. So the same thing happens in paper 2. Paper 2, we also have calculus, but I'll tell you which particular parts we should expect in paper 2. The final areas will be areas that is focusing on section 1 areas. So allow us to begin from paper 2. We are beginning on the graphs. The graph questions, the first graph is called trigonometric graphs. Trigonometric graphs comes from the trigonometric equations, which I believe all of us are privy to. The trigonometric equations include something like, let me just share this. We can have y is equals to 2 sine, let's have the brackets, 3x plus 40 degrees. That is a trigonometric equation. So someone can ask us, draw that graph. Basically, if you're drawing a graph, there are things that you must do. Number 1, we must have something called a table, and that table is to be filled. So the first thing that you must know how to do is, how do I fill the table? There are 3 things that are important in drawing that graph. So number 1 is filling the table. How do you fill the table? I'm aware most of us have got some very advanced calculators which are acceptable by NEC or Kenya National Examination Council. You may be privileged to have a calculator by the name CW. That is the most recent one, I think, approved. And then we have FX82EX, the one with the yellow button on it. Now, those calculators, even the one MS can still feed the values, and then you have the values on the table. So there are always 2 marks for filling that table. You're given the values of X and the values of Y, and then you're told to fill. X is 0 degrees, 30, 60, 90, as we move on to the rest, maybe up to 180 or 360. Using your calculator, you can simply feed this equation in the calculator, program it so that you check what are the values. It will give you all the correct values. But a point of caution here, those values can be required in a particular accuracy, in the sense that how many decimal places should we leave our answer? Now, that will depend on the parts that are filled. In most cases, the table given to us is partially filled. So we are supposed to complete it. In fact, the statement is part A of that question, complete the table below for this equation. Once we have completed that, completing that table will simply mean that you feed this. If I had a point that was given here, maybe let's say this one is 0.4. That was the value that was given in that particular, for the value of 30, we have 0.4 as the value of y. If you feed y is equals to that, put that in the calculator, our x here will be 30. Once you do that, you will get that. That is already filled for us. Then I'm told now to complete it. Completing means the rest of your values must also be aligned to this. That means all your solutions must also be to 1 decimal place. If you have not been told, then the most appropriate one would be, I want to write my answer so that I'm able to plot the graph accordingly. Your scale will determine the amount or the number of decimal points that you will have. Number 2, after completing the table, that is number 1. Number 2, after completing the table, you will go to the graph and then you choose a suitable scale. Choose a scale that is going to help you plot your values. So the scale here will have the X and the Y axis. By the way, this axis are not called X and Y, but we will call them so if the values of X and Y are what we are plotting there. But this is called the vertical axis. This is called the horizontal axis. So if you are supposed to be plotting on the vertical axis the values of Y and then the other side the values of X, then you must choose a scale that is going to help you do this. There are 3 things that the scale must have. Number 1, it must be simple scale. Number 2, this scale must be linear. And then number 3, the scale must be accommodative. Being accommodative, we are saying it is sufficient. Sufficient in the sense that all the values that you have on your table will have to fit the graph that you've been given there. So therefore, if on the x-axis I had values from 0 to 180, then my scale, I must make sure that 0 to 180 will be accommodated within that. If the vertical axis I had, maybe the smallest value was 0, then the highest or the largest value was, let's say, 1 or 2.0, then it means my scale will have to fit those values. That scale is called a sufficient scale. What makes it simple? It is simple depending on the values that I use on the x-axis. The x-axis, I can choose 1 centimeter. On the x-axis, I can say this will be 0, 1, 2, 3, 4, 5. That is a simple scale. You realize that this 1 centimeter in your graph has got some 5 small units, 5 small squares. So if someone wants you to plot 0.5 or 0.6, you will be in a position to identify that particular point very comfortably. If I choose a scale 0, 2, 4, 6, 8, 10. That scale is equally simple because I realize the 5 small squares, if I divide it by 2, it's going to give me easy time to plot the values that I can plot there. 0.2, I can plot here. 0.3, 0.4, 0.5. Remember that the values that are going to be plotting should always be to 1 decimal place. If I have a scale 0 to 5, 10, 15, 20, 25. That is a simple scale, which will give us the same thing. What is this that I'm not calling simple? Assuming we have your scale now 1 centimeter is representing 3 units. So I have 0 to 3, to 6, to 9, to 12. You realize that if I ask you to plot for me where 0.5 is using this, 0.3 is representing 5 small squares representing 3 units. What about 0.5? Where are you going to plot that? Where are you going to plot maybe 2? These are 5 small squares. Where are you going to plot 2? It's not going to be very easy to identify that particular space to plot that particular point. Some of us are still getting in, so I'm trying to buy a little bit of time before I start to move with speed. So that scale is going to be not a simple one. It will be complicated for you. So choose a simple scale to use. Number 3, which is the last one, that scale must be linear. Let us assume that I've used a scale 0 to 2, to 3, to 4, 0, 2, this will be 4, this will be 6, this will be 8, this will be 10. So someone chooses that scale. This scale is very linear. Linear means 1 centimeter, you move from 0 to 2, then the next number will be, in that order will be 4, then 6, then 8, 10. But someone is going to make a mess here and say, this is 0, this is 2, 4. Then instead of going to 6, he'll write 5 there. Then write maybe 7, and then write 9 there. That scale is not linear. It is not linear because 1 centimeter here is representing 2 units. 1 centimeter here is representing 2 units. 1 centimeter here is representing 1 unit, which makes it now not uniform. It is not a linear scale. So that scale is going to be wrong. Remember what we are discussing here is how do I draw a graph and get all the 10 marks? This is a question that is always set in section 2. How do I get the 10 marks in that question? Once I've gotten the 3 things correctly, remember we have said linear scale. It is linear, it is accommodative, or sufficient. We have said it is uniform, linear, accommodative, and sufficient. Then that means our scale will be okay. So the scale mark we will get. Number 2, we will go to the graph and then start plotting the points. Always we plot using these marks. That is the one that is mostly used. But some people always use a dot and then they circle it. The most important thing is that are you able to identify the point that you're plotting correctly? And if that is so, can someone see that this is the point that I've plotted? Is it correct according to what is on the table? So that will give you the plot mark. All the points on your table must be correctly located on your grid. Then finally, if you're talking about trigonometric graph, we're expecting to see a curve. And so if you draw a curve, and that curve is satisfying the examiner, or whoever is seeing that curve says this curve is smooth, this curve has no points where there are bumps or something like that, then the examiner will give you the C mark. Now, this is a little bit subjective, but now what you have to do as a candidate, make sure that your graph, even you can check what you've drawn and see. If you were to mark it, what would you have given yourself? So that will help us. So I've talked about 2 things now. I'm dealing with the trigonometric graphs. Number 1, we've said fill the table correctly. Number 2, have your graph drawn where you will get now the 3 marks, the scale, plotting, and the curve mark. And then finally, number 3 here, now after drawing the graph, we will use our graph now to answer the questions that follow. Now, I want to show you the shapes of the graphs that we will be expecting. If you talk about, we are talking about trigonometric graph, what is the shape of the graph that I will have? Let's check this. Let's check out this. Let's check out this. It's disappeared. All right, there we go. So if I wanted to see a graph, that one here that you're seeing on your screen, that is a shape of a trigonometric graph. It is constant. You know how a wave looks like? That is what we are expecting for a trigonometric graph. Once you've drawn a graph like that, it becomes easier. But anytime you have a trigonometric equation and you're told to draw a graph, and then your graph does not come out as a continuous wave like that, then it means you have a problem somewhere. How do you detect that problem? There must be one particular point where your graph is irregular. That is the point that you'll have to get back to. What are you going to do there? Check. What is the value of X at that particular point? What is the value of Y at that particular point? So you will have to go back to the table and confirm that the value of X is here, the value of Y is here, and are they the correct values that are plotted? So those are the 2 options that you will have. Once you check on that, then you'll be able to correct that mistake. And anytime you have drawn your graph, you can comfortably say that this graph, I think I have all the marks. The biggest problem now is when we are answering the question. There are questions that come after the graph has been drawn, and that is taking at most 4 marks, at most 5. If it is this kind of a graph, I have 2 waves drawn, then it means on the graph I'll get 4 marks, not 4 but 5, where I'll have S1, P1, C1. This is for the first graph. And then I'll need also P1 and C1 for the other curves that we'll draw. So this graph will give you 5 marks. Then now, together with the table, we now have 7 marks. We need to have 3 more marks to go. These 3 marks will be as a result of the application of the questions that are there that you will need to deal with. How do we solve that? If you have these equations, someone is asking you to draw a graph and then use your graph to answer a question. Most students make a mistake of drawing another graph. For example, if this If this was the graph that we were told to draw, and then we are told now, use this graph to solve this equation, 2 sine 3x plus 40. Let me stop the sharing so that the board can be bigger. So we have 2 sine 3x plus 40 is equals to 0. Now you want to solve this equation using your graph. Most students draw this graph one more time, and then they realize it is the same graph that they have drawn. So they have made a mistake. So what are we supposed to do? We must form a straight line equation from here. But this is very simple. This one looks like this, and this value here is our y. So it means here I'm saying y is equals to 0. And from equations of a straight line that you've discussed in paper 1, the line y is equals to 0 is the x-axis. So what about the x-axis? If our curve, like in this one here, let me get back. If our curve, like this one that we have, is that in slide? All right. So that curve, you realize that it is crossing the x-axis at some points. So if you were to solve this equation using the curve, then you realize this is the x-axis. So what about the x-axis that I need to know? What you need to know about the x-axis that where your curve crosses the x-axis, you will read the x values at those particular points. Those will be the solutions of this equation. Suppose that this was given as 2 sine 3x plus 40 is equals to 2. What does that mean? It means this one here, this equation here, is what I write, 2 sine 3x plus 40. The most manual way of doing it is this. So once you're writing is equals to 2, then you will find out, I want to see how to remove this. It means I'll be subtracting. So when you subtract this and this, it's the same thing, so you will come back to 0. This one minus this will be y minus 2. Hence, we have y is equals to 2. So you will be drawing a straight line, number y is equals to 2, which will cross the curve at some points. If it crosses the curve at 2 different points, then you will read, you are expected to read the x component where that line crosses the x, or rather the curve. Where does the straight line meet with the curve? That becomes our solution. Of course, the x components. The second type of graph, which also works similar to the first one, is quadratic graphs stroke cubic. The most important thing that you must know as a candidate is what is the shape of this graph, so that once you've drawn it, you can comfortably say that I did what was there. When I have an equation like y is equals to x squared plus 3x minus 6, so long as the power of x is 2, then that is called a quadratic graph. If I have y is equals to 3x cubed minus 6x squared plus 5x plus 8, the highest power of x there is 3, and therefore that is called a cubic. From the word cube, it's a cubic curve. When I draw these two curves, they look differently. Let's start with this one, the quadratic curve. A quadratic curve will either take this shape or it will take this shape, meaning it turns once. The turning point is at the top there, or it's below here. Those are the turning points of a quadratic curve. So anytime you're drawing something that is not looking like this, then you know you've messed. Sometimes, as I've said, you draw it and you realize it's coming to look that ugly. It means here is where the problem is. So go to your graph and check, what mistake did I make on the table? Did I plot the correct points? Or something like that. So you must know the shapes of quadratic curve. What about a cubic curve? A cubic curve turns twice. A cubic curve can look like this, or a cubic curve, we can have it looking like this. But you can see it is moving. It is now not turning once like the quadratic, but it is turning twice. It has got a maximum point here, and this was a minimum point there. So the shapes of those curves are very important. The same thing as we discussed with the trigonometric graphs. 3 things are involved. Fill the table correctly. After filling your table, draw the graph. After drawing the graph, answer the questions using that. Let's move on to the other graph. The other graph is now called graphical determination of loss. Graphical determination of loss here means now you've been given Graphical determination of loss, you have been given points and you've realized I'm plotting my points, the table have been given. That is how my table looks like. I mean, the plotted points. If you start to join them, you try joining them using a ruler, they don't fit. If you start to join them one after another to form a curve, you will not see that curve. In other words, this one means that you are not going to be drawing either straight line, neither will you be drawing a curve. So what are you going to do in this case? We will draw something we call line of best fits. I want to explain what line of best fit is. Line of best fit is a line that, there are two things here. In physics, we teach line of best fit differently as to opposed to mathematics. What we say in physics is that the line of best fit must pass through majority of the points. For example, if I had 1, 2, 3, 4, 5, 6, then majority will be 4. So at least 4 points will be on the line. If I had 5 of them, then at least 3 of them will be on the line. But that is now not what we are dealing with in mathematics. The line of best fit here, we are going to try as much as possible so that it passes in between the points. It's not a must that this line must pass through any point. I'll pause there so that you get this clearly. It is not a must that this line must pass through any point. See, lazima. It can still pass through any point, some points, 1, 2, 3, or even majority, but it is not a must. What we are going to be interested in here is that once I'm able to draw that line, if it passes through 2 points and other points are left, you will be asking yourself, how many points have been left out? If there are 4 points, then those 4 points must be evenly distributed on either sides of your graph or your line. And how far are these points that have not, my line is not passing through, how far are they from the line? They should be equidistant. This is what I mean here. The distance from this point to the line, the distance from this point to the line, one should not be big. As opposed to when I had maybe this point in the back in Kuchini, then this will be wrong, because when you look at the points up there, the distance from them to the line is not the same as the distance that I'm having below the other side. So it means the line that you're going to draw, the points you leave, they must be evenly distributed. Evenly in the sense that if there are 4, then let it be 2, 2 on either side. And then number 2, the distance from the points you've left up to the line should be the same on either side of your line. What if I've left only 3 points on either side? Then see, lazima. 3, you cannot divide 3 comfortably and live evenly. So if there are 3, then it means you can have 1 on one side and then 2 on the other side. I hope that is clear. Moving on to the other graph, still we're talking about graphical determination of loss. We have line of best fit, which as I've explained. There are other graphs that we are going to be given values on the table. The values on the table will give us something that if we plot, we will get a straight line like that. Or if it is not like that, then it will be looking like this, something like that. If it is a curve, we can have something like a cooling curve, or we have something like this. In linear motion, we can talk about the curves in displacement or acceleration, looking like that. So once this curve has been drawn, then there are 2 things that are possible. I can be asked to answer some questions. The most important questions here, number 1, is to draw a tangent. And how do I know I'm supposed to draw a tangent to answer the question? Let me deal with the first one here. I'm assuming this one is temperature, and this is time. So time is from 0 to 1, 2, 3, 4, 5, 6. Time in seconds. And temperature, let's say 20, 40, 60, 80, 100. So that is a cooling curve. Someone is asking you a question. Find the temperature when time is 3. Find the temperature when time is 3. When T is equals to 3. Find the temperature when T is equals to 3. That means you're talking about instantaneous. At the instant when T is 3, what is the temperature? When T is 3, we are coming to the curve, and this is where we reach. At that point, I want to get the temperature. I'm not going to read this. That is what I'm going to have. The temperature when T is equals to 3 will be that. All right? Someone is going to ask you, find the temperature, the change in temperature after 3 seconds. After 3 seconds means from 0 to 3. What is the change? That change, I'll check from 0, what was it? Assume this one was coming from the y-axis. So this is where the temperature came from, let's say 120 degrees if possible. So 0 to 3, after 0 to 3 seconds, how did it change? That is the change. So the average change means we will take the temperature at 0, the temperature at 3, which will be around 30 here, at 0, 120, then you get the 2. Alternatively, if we wanted to get the temperature when t is equals to 3, then we will be drawing what is called a tangent to the curve at that particular point. After drawing that tangent, the next thing that we'll be doing is to get the gradient of that tangent, and that will be the rate of change of the temperature. Let's get this clear. What is the temperature when t is 3? I will read that directly. The second question, what is the rate of change of the temperature? The rate of change will be the gradient of the line that you're drawing. But this is a curve. A curve does not have a gradient, and therefore, or rather, it does not have a constant gradient. Therefore, we are going to have what is called the instantaneous gradient, which will be given as a result of the tangent drawn. So at t is equals to 3, what is the rate of change? The rate of change will be the gradient at 3. And the gradient at 3 definitely will be a tangent drawn. So you take your ruler and then you draw a tangent. A tangent is simply a straight line that touches a curve at only one point. So we have talked about what is the average rate of change from t is equals to 1, from t is equals to 1 to t is equals to 3. What is the average rate of change? The average rate of change from t is equals to 1 to t is equals to 3, we will come here. T is equals to 1, I'll get my temperature there, assume it is 70. T is equals to 3, we have assumed it is 30. So the average means it is changing from 70 to 30. So take that, 70 plus 30, you divide by the time period. That will give you now the average rate of change. Maybe a recap. Two things on such graphs. We can be asked to calculate, or rather to test, what is the temperature when t is 3 or when t is 4. You will go to the diagram and read directly. But if you talked about the rate of change, then what is the rate of change when t is 3? I will be getting what is called the instantaneous rate of change in that case. Let's move on to the next graph. The next graph is this. Graphical determination of loss, that is what we have talked about. We have also mentioned the rate of change in that case. So we have a graph of matrices and transformation. Matrices and transformation. What is the expectation? You're given a graph and you're given a triangle. A is 2, 1, B is 3, 6, and C maybe is 4, 5. And this is a matrix of a transformation. You're told, transform this triangle using this matrix. We have always given a method called the Moy method. Moy means matrix multiplied by object will give us the image. Meaning, if I pre-multiply, the word pre means it comes before. If I pre-multiply the object with the matrix, then I will get the image. Please don't interchange this. That is wrong matrix multiplication. Remember, if I have two matrices, A times B, if I multiply them in that order, it will not give me the same thing as if I multiply B times A. So it is important that we know if I'm doing a transformation using a matrix, where do I put the matrix? The matrix must come before the object. Therefore, I will write also the coordinates as a matrix. So this will be A, this is B, this is C. If I do this, this is 2, 1, 3, 6, 4, 3, or 4, 5. This will give me the image A prime, B prime, C prime. So you do the multiplication and get the image. In this case, you can see we are going to have 2, 3, 4. Then we'll have -1, -6, and -5. This now has given us the image. Someone is going to ask you, get the image of this triangle when we multiply it by this matrix. That is what we have gotten. But remember, this is a matrix. That is not an image. So if you are getting the image, then you must write the coordinates. What are the image? You will come back and say A prime is 2, -1. B prime is 3, -6. And then C prime will be 4, -5. That is now the best way that we will have written the coordinates. If you are asked to state the coordinates, make sure the coordinate is written the correct way. A coordinate must have this bracket. A coordinate must have this comma in between the numbers. If the comma is not there, then that is now not a coordinate, but it's now turning to be another matrix altogether. So this is what we are supposed to have. State your coordinates correctly. So once we have done that, we will be able to plot the image and then even see what is it that this matrix is doing to the object. We can tell this matrix has moved the object from this point, and this is how now the image is looking like. The transformations that we'll be dealing with, you now need to understand. If that matrix, or rather that object changes from first position to the next position, then the question would be, which transformation did that? In other words, now, we need to understand the types of transformations that we have. In Form 2, we have transformation which we are doing, but we are not doing them with matrices. We are doing them with, let's take an example. We have rotation. We have reflection. We have enlargement. Then we have translation. Those are the transformations that we deal with in Form 2. But then, in matrices, we don't deal with the translation. Translation is just a vector, and therefore, we don't deal with it when you're talking about matrices and transformation. What we deal with now, we add some two. One is called shear, another one is stretch. So having mentioned that if I have any matrix, the matrices can fall in between any of these 1, 2, 3, 4, 5 transformations that we have. You as a candidate must be in a position to see which is the transformation represented by a matrix. That is number one. Number two, what is the matrix representing a given transformation? For example, if you're talking about a reflection on the x-axis, the x-axis line y is equals to 0. What is the matrix representing that reflection? So you must be in a position to do that. The easiest of them all, the easiest way to get that matrix is by use of a unit square. How do I use a unit square? You must know how a unit square looks like. Of course, this one point is 1, this one is 1. So it is a 1, unit means 1. Therefore, a unit square is a square with one side. I mean, the length of each side is 1 unit. That is it. So if that is the case, from origin to I is 1 unit, from origin to j is 1 unit, even I to k will be 1 unit, j to k will also be 1 unit. So how do I use this unit square to get the matrix representing a reflection on the line y is equals to 0? The line y is equals to 0 is just this x-axis. Simply reflect this. Your point will be, how do I get this image? The image of I and the image of j will give you that matrix. For example, if I'm reflecting this point I on the x-axis, of course, the image will be on itself. Therefore, this point is 1, 0, so it will remain there. What about 0, 1? Where does it go? 0, 1, definitely after reflection will come somewhere down here. It will be 0, -1. So this is what we will have. And therefore, this one is the matrix already. That is the matrix that is representing a reflection on the x-axis. If I want a reflection on the line y is equals to x, line y is equals to x is this one here, the one that passes through 1, 1. So it must pass through that point. This is line y is equals to x. What is the matrix representing its reflection? The only thing I need to do, check where will I go to, where will j go to. When I'm reflecting it on this, you can obviously see that point I will come to where j is, which is 0, 1. That is the most important thing. What about point j? J, when reflected on this line, will move down the other side. That is 1, 0. So that becomes the matrix representing that transformation. I don't want to move on to so many of them. We have a rotation, we have shear, we have a stretch. When we talk about, let me mention something briefly about shear and stretch. I know most candidates fear the stretch and shear thing. If I'm having a shear, then you must be able to identify the matrix. Let us assume the shear we are going to do using a matrix will have the x-axis invariant or the y-axis invariant. If the x-axis invariant, it means points on the x-axis will not change, and therefore it becomes the invariant point. Every other point will move parallel to the invariant line. Therefore, j and k will move along that line. So I can have my j prime going there, and then k prime moving up that point. So that means this image will look like that. That is the shear with x-axis invariant. The same thing I can do with y-axis invariant. If y-axis invariant, it means point O and j will never move. So either I can move I and k upwards or downwards. If I choose to bring them downwards, it means k will be somewhere here, and then I prime will be somewhere there. So what happens? My image will look like this. So that is the image after the shear when I say the y-axis invariant. The same applies to the stretch. How do I deal with a stretch? The same way, stretch we can describe when x-axis invariant. So that is point A, that is J, this is K. If the x-axis invariant, it means it is J and K which will move. They will move perpendicular to the invariant line. Anytime you're doing a stretch, then it means you're going to move. If the invariant line is given as the x-axis in this case, then you will move the other point perpendicular. So perpendicular to the x-axis means either it is vertically upwards or it will move vertically downwards. So ij will move up there, j prime, k prime will be there. So that will be my image, which I will draw. I've used a dotted line here, but know very well that anytime you're drawing graphs or you are giving your values, do not use dotted line to show the images of the points. All right, I think that is okay. Maybe I can just mention something briefly about the shear. Sometimes someone gives you an image and an object on a graph, and you have been told that this is a shear. You must tell us what is the invariant line, or describe for us the invariant line. The description of a shear, I've forgotten that. I think I'll get back to it. All the transformation must be described accordingly. So if you're talking about a shear, someone has given you an object and its image and a shear. And then you're told now, can you describe for us the transformation that takes this? For me to describe a shear, I must mention the invariant line. That is number one. Then number two, so if you have a shear, number one thing that you must mention is the invariant line. Then number two, we must talk about the shear factor. If we don't talk about shear factor, then we can replace that by one thing. We can take an object, let's say point A, which is 2, 3, is mapped onto A prime, let's say 410. That is another description of the shear. So we can either say invariant line is constant for both of them, both descriptions. Then I say the shear factor, and or I can say a point. This point you're picking here must not be on the invariant line. So if you're telling us point A is mapped onto A prime, it must not be on the invariant line that you have identified. But how do I identify the invariant line? It is very simple. One rule that you're going to write down so that you follow. I will not explain it here further, but you must remember that any line of the object, if I had this as my square, if I had that as my square, this is square, let's call it A, B, C, and then D. And then you're told that this square was given a shear. Let's say it goes up to that point. So this one would be D prime, and then this is C prime. So this is A prime also. This is B prime. So someone has given you this and has not mentioned what is the invariant line. the easiest way to identify the invariant line, check any line on the object that is not on the invariant line. This is a square. A square has got 4 sides. Line AB is on the invariant line. Line BC is parallel to the invariant line. I'll not use it. So what will I use? I'll use AD or BC. Lines that are not on the invariant line, or they are not parallel to the invariant line. So what I'm going to do is check. I will check the image of AD. AD is here. The image of AD will move like that. A prime, B prime. You will realize that those 2 lines meet somewhere. Wherever they meet, that point is on the invariant line. If I take another one like BC, it is not on the invariant line, neither is it parallel to the invariant line. Therefore, what is the image of BC? BC is here, the image of BC is there. So if I draw the 2 of them, they will be meeting at point B. So these 2 lines, if I join them, they are forming some straight line, which equation can be comfortably found. That straight line is the x-axis, and therefore we will make a conclusion that the x-axis in that case becomes the invariant line. If you do that procedure and you realize that the line is not to the x-axis or the y-axis, then be in a position to find the equation of the line that you will be finding. It is not a must that invariant line must be the x-axis or the y-axis every other time. Let's get back to our story here. Ogive graph. Now this is statistics. That is statistics. What I'm expecting you to know in statistics graph, the Ogive graph is the cumulative frequency curve. What are you drawing on the x-axis? What are you drawing on the vertical axis? Suppose our graph was values 0 to 10. Let's say 0 to 9, and then 10 to 19, 20 to 29, 30 to 39, etc. That is what we had. Maybe 4, 6, 8, 5. I want to do an ogive on that. So what I need to do, I will be drawing, these are max, and this is F. The first thing that I'll do is to get what is called the CF values, cumulative frequency. So if we construct them, 4 plus 6 gives us 10, plus 8, 18, plus this is 23. Maybe we can add another plus here to be 40 to 49. Maybe this will be 7 to give us 50. If that is what we have, then the expectation is we will be drawing the CF values on the vertical axis. And here we will be drawing the max. If this were max, just come and write max here. Don't write boundaries, don't write limits, just write max here. But you know, if you're doing this, then we'll be plotting the upper class boundaries of those classes. So the first upper class boundary here is 9.5. Another upper class boundary is 19.5. Another one here will be 29.5. Now choose your scale, and again, make sure your scale satisfies those 3 properties that we had talked about. I will have my centimeters like this. Now look at what this student will be doing. This is 0. Because this is starting at 9, the first upper class boundary is 9.5. A student will be writing 9.5 there. Then for convenience, he will be writing 19.5, 29.5, 39.5, 49.5. Now that scale is not correct, and it is some mistake that most students have always been making. Why is it not correct? It does not satisfy one of the 3 conditions that we gave. Which one is that? If you look at this is 1 centimeter, and the interval here is from 0 to 9.5. We cannot say that the lower boundary here is negative 0.5. It is not. The lower boundary here is 0. So from 0 to 9.5, the interval there is 9.5. But this other case, from 9.5 to 19.5, the interval is 10. Therefore, that scale is not linear. So it is a wrong scale. What then can this student do? There are 2 things. The first one, this student can just write here 0, here 10, 20, 30, 40, 50. That will be okay. And because we know we are plotting the upper class boundaries, you have identified that here, the upper class boundary is 9.5, here is 19.5, here is 29.5, 39.5, and then 49.5 there. What we will be doing here is just identify, because this scale is now okay, come and identify where your 9.5 is, slightly before 10. So you must identify 9.5 against 4. Let us assume this was up to 50. So I can say this is 10, 20, 30, 40, 50. So 9.5, which is somewhere here, I'm plotting against 4. Then 19.5, I'm plotting against 6. 29.5, not 6, but 10, sorry. 29.5, I'm plotting against 18, which is there. 39.5, that will be plotted against 23, so that will go there. 49.5, I'll plot against 50. Am I right? 10. Wait, this was supposed to be 30, not 50. This was supposed to be 30. So this was supposed to be 30, up to 30. So this graph, you see, you have started plotting this particular point. So don't be quick to start joining these points to form your curve. Know that this curve must rest on the x-axis. So what shall we do? The x-axis, the point on which is going to rest, should be the lower class boundary of this class, which is this. So it's going to move from there. As it moves, then you draw your curve in the very smooth way that is possible. That will be the CF values. Let me get back to this scale. What is the other option that we have here? The other option will be, I can choose to break this graph. Breaking, just use that, those wavy lines. It means, this breakage means there are some values that are here that we are not dealing with. I'm not interested in them. Then you come and write. Now, this is a case which is possible if this graph was beginning, let's say, at 10. So we didn't need that, meaning I'll come and start the first class as 9.5. I didn't need that one because the first class is 10 to 19. So you can do that so that it begins from the lower boundary of the first class. Then you write 19.5, 29.5, 39.5, 49.5. Then again, you move and plot the boundaries against the classes. The boundaries against the CF values. Boundaries against the CF values. Then the first point you plotted, you realize your curve cannot start there. It must begin on the horizontal axis where we have our graph beginning. So that is an example of an ogive curve. You can see it on your screen. You can see it on your screen. I think the other one, which the last one now is linear programming. Linear programming contains 3 things which you must know. The 3 things that you're going to be dealing with include formulation of obtaining the linear inequalities. Obtaining the linear inequalities, you can see them on the screen before I stop sharing that. Obtaining the linear inequalities from the story, from the literature. So you have to be a very good student of English so that you read and understand, use the correct inequality symbols, and you know how to represent those inequalities on a graph. After you have your inequalities, the next thing is you draw those inequalities. I'm sure in paper 1, you are aware of how to represent inequalities on a graph. It's very easy. Number 3, we are going to be doing what is called now the linear programming bit, that is optimization. Optimization means we are going to look for the minimum value or the maximum value, depending on the parameter. What did we intend to do in the linear programming? Did we want to maximize profit or we wanted to minimize the cost? That is what we'll be dealing with. So having done that, the other thing now, we are going to do something called drawing the search line if we have that particular statement that is giving you what is called the objective function. I have a graph here which was represented representing inequalities. That is an example of a linear programming question. You can realize that the point R of the region R in that particular case is bounded by some 4 lines. Some lines in that case, you will realize they are dotted depending on the inequality that is used. And if you're using those inequalities, make sure they are the correct inequalities. Now, one thing that I want to mention there, if you are identifying the inequality to use, what should be the guiding factor? The guiding factor for the inequality to be used will be, number 1, I have to use this symbol or this. That is less than or equals to. When do we use less than or equals to? This one is used when we have resources limited. When we have limited resources, then we are going to be using this. Let me take an example. I have 1,000 shillings to spend, and this 1,000 shillings I'm spending, I'll spend it on some pens and some books. So the amount I've spent on the pens is X. The amount I'm spending on books is Y. So the amount I'm going to spend must not be exactly 1,000, but I can spend something less than 1,000. Maybe I'll remain with some balance of 2 shillings, 50 shillings, or something like that, which will give me that inequality. But I cannot have it greater than. You cannot spend more than what you have. So if resources are limited, then that will guide you. Let's take another example that the number of students that I'm going to transport to a particular event should not exceed 200. Or if I have 200 students to transport, what does that mean? Does it mean that the resources are available or something is happening? A duty is to be performed. So if a duty is to be performed, then this is what I'm going to be used. Duty is to be performed. What is the duty that we're performing? I have to transport the students. Let me assume that I have girls and boys. The number of girls is X, the number of boys is Y. So the number of girls that I'll have and the number of boys I'm going to have should be either greater than or equals to the 200. Because you have to do that. You cannot do less than that. It can't be less. You have to take the 200. So it's either 200 yourself or greater. I hope that is very clear. That is a way you can identify the symbols to be using. The next area we say we have 6 areas. The next area which I want to brush through very quickly is commercial arithmetic. Someone is here, yes. Commercial arithmetic and the related areas. Commercial arithmetic and related areas. That is the other area that I want to mention. Commercial arithmetic. And related areas. So boys and girls, ladies and gentlemen, after mentioning the graphs that we have talked about, there are 6 graphs that we have discussed. Be in a position to comfortably do all those graphs if you're preparing for KCSE, because definitely you will get at least 2 graphs, 2, 3, or 4 graphs that will be set. And don't say that me, I don't do graphs. I need to do the other questions. So those ones I'll choose. Yes, in most cases, those questions are set in section 2, but we can also have graphs set in section 1. Number 2 that we are talking about here now is commercial arithmetic and related areas. When we talk about commercial arithmetic and related areas, I'm expecting you to know these facts here. You can look at your screen. You can look at your screen. Sorry for that. Look at that one. We have simple interest, compound interest, appreciation and depreciation, and then we have hire purchase and income tax. A good student will know that that is all about commercial arithmetic 2 that we'll need to do. Commercial arithmetic 2 is in Form 3, and therefore I want to believe Form 3s and 4s that are here have known that. The simple interest formula, please remember that formula. The formula for simple interest, you know how it looks like. Simple interest is equal to P times R times T over 100. Once you've written that, you must know what P means. It's the principal of the deposit. R is the rate of interest, and then time is the period of interest. Of course, you're dividing by 100 because the rate must be a percentage. Then we talk about the compound interest, and then appreciation and depreciation. The other area under this commercial arithmetic is series and sequences, and then mixtures and compound proportions. So I may not dwell on mixtures, but allow me to start with the commercial arithmetic and talk about the compound interest. compound interest formula is on your screen. I hope we know that. So we must check. If someone wants you to compound some money, then the compound interest is the first formula that is given there. A is equals to P into 1 plus R over 100 raised to power N. This compounding can be done yearly. If it is done yearly, then that is the formula that we will have. A is equals to P into 1 plus R over 100 raised to power N. Of course, N here means the number of interest periods. So if the compounding was done yearly, then the number of interest period becomes the number of years. So if it is 3 years, then N will be 3 years. If someone tells you, a point of caution here, just see the board. If someone says that I have 10,000, this is the money that has been deposited in an account. This account is producing or giving interest at the rate of 12% per annum. And then we want to get what is the amount that this money what do we have in our account after a time span of 2.5 years? Of course, the formula that we will be using is A is equals to P into 1 plus R over 100. I want you to be very keen here a bit. Our principal here is going to be the amount, which is 10,000. This is 1 plus R. We are now doing the compounding yearly. If this money was compounded per annum, then I will have R, which is 12, over 100 raised to power the number of years. Because the number of years is 2.5, 2.5, most of us will be writing 2.5 here. And that is where the problem is. I want to explain that anytime you're using the compound interest formula to do a question that is asking you to get an amount after a period of time, make sure the value of N is an integer. Make sure the value of N is an integer. It cannot be a decimal number. Why? The compounding is done yearly. It means if we have 2.5 years, the complete number of years are 2. But then we will have a half year which will not warrant any compounding of that money. And therefore, we are going to only do compounding twice. Therefore, we use our N is equals to 2. I hope that is home. So once I've used that as 2, I will evaluate this, get my value. What does that mean? The value I'll get here will be the amount after 2 years. But we want to know how much money is there after 2.5 years. So after 2 years, this is what we'll be getting. I don't know how much this one will be. Those who have a calculator can do it. But I'm assuming let's get an amount like 15,000. It is not true, but assume that is what we have for to save time. So if you have 15,000, that is the money that is in the account after 2 years. But this money is remaining there for another 6 months, which is a half a year. What happens in those 6 months? We are going to calculate simple interest on this money. So we will be calculating simple interest and say our principal here will now be 15,000 times the rate. Remember our rate here was per annum, but we want to get the interest in those number of months. So we must convert this rate to be monthly. So if every year, which is 12 months, the rate was 12%. What about the rate that is there per month? That will be 12 divided by 12 to give us 1. So that will be 1 times T. T is the number of months, which in this case will be 6 over 100. Whatever we get here, we will add it onto this to give us the amount of money at the end of that session. I hope that is clear. If someone says that this money was compounded semi-annually, the formula is there. That is what we will do. And again, remember that the integer N must also be there. It must just be the integer that is used as N. If it is semi-annually, you can see what I've written there. So we have R. R is divided by 2. That's why I put R there. But you can divide it and then you remain with the 100 down there. But your N will be 2 times the number of years. If it is quarterly, you can see R will be divided by 4. And the number of years will be multiplied by 4 because a year has got 4 quarters. So we'll get that as our amount at the end of that time. Now, if we are using the same formula for appreciation and depreciation, as you can see on your screen, that is what we have. Suppose an item was left, or rather was bought at 10,000 shillings and it is appreciating at a rate of 12% per annum. And then I want to get the amount of its value after 2.5 years. I want to say clearly that in that case, we accept that the value of n can be a decimal number. The value of n can be a decimal number whenever we are using appreciation or depreciation. So we can use a fraction or a decimal number. We are not insisting on the integer. But if it is compound interest, then I'm saying the compound interest there, we must ensure that that is an integer, because the interest period are exact. We cannot have a half an interest period. If the interest period was 6 years or 6 months, then I cannot have an interest period of 1 month in that particular case. Hire purchase, we need to know those terms. This one that is not, we know the formula for hire purchase, that is written there. So we have the deposit and then the total installments. Total installments gives us the monthly installment times the number of months. But then someone is going to ask us the difference between the hire purchase price and the cash price. That is the interest. That interest has got a name called carrying charge. So the carrying charge is given as the difference between the hire purchase price and the cash price. That is what we will have. So how do we calculate the rate of carrying charge? How do we calculate the rate of carrying charge? The rate of carrying charge, let me take this example. An item was costing, let's say, cash price 20,000. Then the hire purchase price, let me just say, the monthly installment was 1,000 times 18 months. So in this case, our hire purchase price will be 20,000, which is the deposit. No, not that one. Cash price is 20,000, and then I have monthly installment of 1,000, 18 times, but I gave a deposit, let's give it 15,000. If that was the deposit that I gave, so we have 3 things, the deposit here, monthly installment, and the number of months. So we want to calculate the hire purchase price. Hire purchase price this time will be given as the deposit, which is 15,000, plus the total installment. Total installment is 18 times 1,800 will be 18,000. This will give us 33,000 as our hire purchase price. So the question is, the difference between the cash price and the hire purchase is 13,000. 13,000 is the interest that the seller got on that particular item. What is the rate of that interest? We will get back to the formula, compound interest formula, and calculate the rate of that interest. So now, in this case, we must identify what is my amount, what is the principal, what is R, and what is N. Remember that if this thing was supposed to be costing 20,000 and we gave a deposit of 15,000, as you carry the item away with you, you are going with a debt. And that debt is the difference here. The difference between the cash price and the deposit is the principal, which we'll be getting as the interest. So what do? We will take the 20,000 minus 15,000. That will give you 5,000. Then times 1 plus R, the rate we don't know, that is what we are looking for. Then raised to power N. Power N, our N is what? The number of months, which is now 18. Then this one is given something. What is A? A is the total amount. Total amount, this person, instead of bringing the 5,000, which was the balance, brought 1,018 months time. So this gives us 18,000. So this is giving us 18,000 total installment. So if we are calculating the rate of interest in a hire purchase, then we must know what is the amount. The amount will be the total installments. The principal will be the difference between the cash price and the hire purchase price, and the deposit. And then N will be the number of monthly repayments that have been given. I think that is clear with us. Let us go to the next part. If you have a question, you can just note it down so that we can get it. The next part is now income tax. The next part is income tax. Let's see. Income tax has got some few things here. Maybe I'll just explain what we have. When we're dealing with income tax, we must know some terminologies which are very important. Number one, know what is called taxable income. Taxable income is the amount of money that is being taxed or subjected to taxation. So if you know what taxable income is, then you must be able to calculate the correct taxable income. A mistake arises in questions, a structured question for income tax, a 10-mark question. The first question is always asking you, calculate the taxable income. How do we calculate the taxable income? Taxable income is the amount of money that is taxed. So I must be in a position to read through the question and see, are there some stories that have been given that is going to make my taxable income different? What I'm trying to say is that you must make sure that the amount of money you're going to subject for taxation must be the correct value. If it is wrong, then it will jeopardize or it will mess up the subsequent parts of the question, because you're going to take that money to the table, you tax it on the slabs, you'll be getting the net tax, you'll be getting the net salary to end your question. Then you realize that if you had the wrong taxable income, then it will be wrong. Basically, taxable income is given by basic salary plus all allowances. You will be told. That is the basic thing that you must know. Basic salary plus all allowances, that gives you what is called the taxable income. Now, if something is going to change, then I must read through the question and say, what is it that is going to change? Someone can say, allowances that have been given, there is an allowance, one of them, that is exempted from taxation. If the word exempted is included, to exempt means to free of. To exempt means it is now not going to be taxed. So if you're told that I had 3 allowances, for example, a house allowance of, let's say 10,000, I have a medical allowance of 6,000, for example, and I have a commuter allowance of 5,000 shillings. And you're told that this commuter allowance is exempted or exempt from taxation. Then it means if you're calculating, assuming our basic salary was 20,000, if I'm calculating the taxable income, I'll take the basic salary plus only these 2. I'll now not take all the allowances because I've been instructed that one of the allowances was not supposed to be subjected for taxation. It is exempt. So that will be it. I'll have that. So you must read through and get the correct taxable income for yourself. Now, what other scenarios do we have? 80% of the questions will have basic salary plus allowances, but sometimes someone can tell us that someone has been housed. Any moment you see that someone has been provided with a house by the employer, then things change. Now we'll not be doing basic salary plus allowances. So long as you've mentioned something, someone has been housed, then we're going to say our taxable income will be 115% of the basic salary plus allowances. If someone is a house, then it means we'll be talking about 115% of the basic salary. 115% means I'll take 15% of the basic salary, I add on to the basic salary, and that one will be added to all allowances that are there. That gives us the taxable income in that case. Another scenario is someone has been housed and is paying nominal rent. There is something you're going to call nominal rent. Nominal rent. If someone is a house and is paying nominal rent, then our taxable income in that case, those are rare cases, and we must equip ourselves with it. Taxable income will still be this 115% of the basic salary. We'll add the allowances, yes. But because he's paying nominal rent, we will subtract that rent. subtract the rent from 115% of the basic salary plus allowances. So take 115% of the basic salary plus allowances, subtract the rent. Whatever is left is now what we'll be calling the taxable income. You subject that to the table. I hope we know how to tax. Only tax what is given. Tax what you have, the taxable income. Tax that. Once you subject that money to the tax table, whatever you will get there will be called the gross tax. Gross tax, sometimes they give us different terminologies. This is the total tax. So if someone says calculate the total tax or tax charge, someone can mention that, calculate the tax charge. So that is the total or gross tax that we are dealing with. So those terminologies should not be confusing to us. So if we have gross tax, we have calculated the total tax. The next thing someone is going to ask you, it is a sequence here. We'll be getting what is called the net tax. Net tax is what is called the tax paid. We can also call the pay as you earn. So any of those terminologies can be used to ask you the same thing. So how do we get the net tax? Net tax is given by the total tax, which is gross, minus what is relief. Reliefs can be in different names. We can be talking about personal relief, family relief, insurance relief. If the reliefs have been given more than once or more than one, then what you need to do is add all of them together. And then you say, my relief 1, relief 2, relief 3, put together gives you your total relief. Then you will give the net tax as gross tax minus the total relief. Whatever you will have there will be your net tax. That is the amount that money gentleman is going to pay, or the lady. After getting the net tax, the tax that we are paying, someone is going to ask you somewhere there, what is the net salary? What is the net salary or net income? Net income is what remains after you have removed everything. So this is what we'll say. Net income is equals to total income. Total income. I'm not saying taxable income. I'm saying total income. Net salary is total income minus total deductions. Net salary is equals to total income minus total deductions. I'm very careful with this because of this scenario where someone was being housed. If someone was being housed, you remember we talked about 115% of the basic salary to calculate the taxable income. 115% of the basic salary is not someone's income. We have simply inflated that income so that this person can pay more tax simply because he's paying more tax because he has been provided with a house. So when someone is getting the net salary, take your total income. A simple case, total income means basic salary plus all the incomes, all the allowances, sorry. Basic salary plus all the allowances, whatever comes into your account, that is the total income. The name is basic salary and any other allowance that is there. That gives us the total income. Don't use taxable income for this. But it can be taxable income if the basic salary, or rather the taxable income was given as the basic salary plus allowances. If that was the case, then yes, total income is our taxable income. That's what we taxed. We have mentioned something here called total deductions. Deductions are some money that we remove from our salary or our income. These deductions are going to be named. We have insurance premium paid, that is a deduction. We have NHIF being paid, that is another deduction. We have water bills, we have electricity bill, we have so many other things. All those deductions, we call them specified deductions. So the deductions that we need to talk about, and you have to be very careful here. The first deduction that we are not going to be forgetting is the net tax. Net tax is your deduction number 1. Number 2 deduction will be any other specified deduction. Any specified. Any specified here means, I've mentioned an HIF. You are paying or repaying some loan. You have insurance premium you're paying monthly. And then if this person was housed and was paying a rent, then that nominal rent is also a deduction. Don't make a mistake and say, because we had subtracted nominal rent when we were calculating the taxable income, now we don't subtract it here. The reasons for the two actions are different. So nominal rent is one of the deductions. So you take net tax, any other specified deduction plus the nominal rent, if it was there, that will give you the total deduction. Subtract that from the total income. Whatever is left becomes the net salary of that individual. Let's go to the next stage. This next stage is called geometry. The next stage is geometry. Under geometry, we have these three things: vectors and three-dimensional geometry. We have latitudes and longitudes. We have loci. I will not go through the details of each of them, but I'll mention a few things that we need to know so that I also give you time to answer some questions. Under vectors, we are not going to deal with vectors 1 if we are talking about paper 2. Paper 2, we are going to insist on vectors 2. Under vectors 2, there are a few things that I will expect you to know. I'm going to mention that three-dimensional geometry, the same thing. If you're talking about loci, the same thing. So let's maybe begin with three-dimensional geometry. As you can see on your screen, I'll be very quick to mention that if you have a diagram, a three-dimensional diagram, there are lines on that diagram, there are faces or planes on your diagram, then we have lines which can be meeting somewhere. If these lines meet, the most important thing is that we are going to be asked to calculate the angle between the lines. So the first one is we will check if I have a line and another line, how do I calculate the angle between the two lines? If you have to do that correctly, then the best way is you must form a right angle, or you should form a right angle triangle where you will be in a position to use the trigonometric ratio, SOHCAHTOA, famously known as SOHCAHTOA. So if you have a right angle triangle and one of the angles you will have identified, you call it theta, then you know if you're using sine, then sine theta is equals to opposite over hypotenuse. Tan theta, you know, tan theta is opposite of adjacent. Cos theta will be adjacent over hypotenuse. So that is what will help you to get an angle between a line and a line. That is the most fundamental one. Then we talk about angle between a line and a plane. In that case, you must know what a projection of a line is. So you can go and find out what a projection of a line is. So if it is an angle between a line and a plane, then you have to look for the angle between the line and the other line, which we will be calling the projection on that given plane. Angle between a line and another plane, between a plane and another plane, we will be talking about two lines. We will also come up with some two lines and get the angles between that. I will not have enough time to demonstrate that. Be in a position to also know skew lines. Skew lines are lines that do not meet. And if we have to get an angle between them, someone will be asking, if they don't meet, how then do we get an angle between them? We will translate one of them from its plane to the plane where the other one is, so that we are able to see they will be meeting. Translating here means you take it and you move it parallel to where it's coming from, and that will be it. Latitudes and longitudes. Latitudes and longitudes is another one for geometry. Know how to identify position of points on a globe. The most important thing is know how to calculate distance between 2 points. That is very key. So the distance between 2 points, you must be able to calculate in nautical miles as well as in kilometers. You must know the formula. I think I'm going to write the formula here so that we briefly discuss about that. But the most important thing is get the distance. You know how to get the distance in both units. You cannot do that if you cannot identify where these 2 points, whose distance you want to get, lie. One, they can lie on the same small circle. And we must know that small circles are all latitudes, with the exception of the equator. Or we can have a great circle, and where a great circle here will be all all longitudes. That will give us the the distance that we need to get. So let's see this. I want to just highlight the formula that we need. Those are the concepts that are very crucial in this. You must know and know how to use them. If I'm talking about a small circle, let me talk about a point A, 30 degrees north, 40 degrees east, and a point B, same latitude, maybe 90 degrees east. I want to get the distance. Number one, if I want to get the distance in kilometers, then what is the formula that I'm going to use? The distance in kilometers will be given as, of course, remember that these 2 points are lying on a circle. So if I'm getting the length of that circle, it means it's the length of the arc. What I need is simply the angle here and the radius. The radius there becomes the radius of the small circle. And radius of a small circle is given by capital R, cos latitude. Capital R is the radius of the arc, will always be given. If not given, then we have a constant one, 6370. You can check this from the mathematical tables as well. So if you want to get the radius of any small circle, then it is capital R, which will be this, times the cosine of the latitude we are dealing with. In this case, our latitude is latitude 30 degrees north. So it will be R 6370 times cos 30. That will give us the radius. So all of us are aware, if I want to get the length of this arc, I need this angle. That angle will be the difference now in the longitude. So in other words, if I want to get that distance, then what I need here is the longitude difference over 360 times 2 pi r capital cos latitude. Remember, it is 2 pi r. So that is what we'll have. So 2 pi r cos latitude, that will give us the distance along that small circle. If I want this same distance in nautical miles, then I'll just have the longitudinal difference. Longitudinal difference times 60 cos latitude. That is, some of us use alpha times 60 cos theta, whichever letters that your teacher taught you. I know they mean the same thing. So longitudinal difference, in that case, we'll maybe use alpha for that, times 60 cos theta to give you the distance. So once you know how to do this, very crucial, you cannot do longitudinal latitude if this is not some of the information that you have. I have 2 points. This is number one, a small circle. What if I have a great circle? How do I get the distance along a great circle? Let me use that. And let me use 30 degrees south, 40 east. So that is what I have. Those 2 points, I can see they share the same longitude. So if they share the same longitude, what am I supposed to do? I'm supposed to find the distance between them. It means these points, the longitudes, we had talked about all longitudes being great circle. So we need to just use the correct formula. So identify that formula. I'm just reminding us, this case, it will be the difference in latitude. So we talk about latitudinal difference over 360 times 2 pi r. That is a simple bit of it. Then if I want it in nautical miles, then I'll just take latitudinal difference times 60. That will be the distance in nautical miles, and you'll be good to go. Be in a position to tell the time difference. Time difference will be as a result of the difference in the longitudes, and any 1 degree difference in longitude is equivalent to 4 minutes different. You must also know very well that if I want to get time difference between a point and another, let me take an example here. I have point A and point B, 40 degrees south, 100 degrees east. Between point A and point B, one of them has its time ahead of the other. We always say that points which are on the east, where the sun rises from, their times must be ahead because they have their mornings earlier than the others who are on the western part. So therefore, this point B will have its time ahead, assuming that at A, we were at 8 a.m. Someone is asking you, what is the local time at point B? The local time at point B, we will check the longitudinal difference. In this case, I'm seeing 60, 40 east and 100 east. That difference is 60. 60 by 4 will give us 240 minutes. 240 minutes divided by 60 will give us how many hours? That will be 4 hours. So it means the difference in time between point A and B is 4 hours. After getting that difference, the next thing that we need to ask ourselves is, what is the time at point B? The time at point B, we have identified that B is having its time ahead. So we will subtract. If the time, or rather now we have the time at A. So if the time at B is ahead, it is 8 a.m. at A. So we have to subtract this from there so that we get the time at point B. If we were given the time at B, then we will do the opposite so that we get the time at point A. All right, I think that is what I can say about that. Of course, speed and under latitudes and longitudes, we have the speed given in kilometers or nautical knots. Be in a position also to discuss that. Let us go to loci. Loci, allow me to explain briefly in 5 minutes. I know most of us dread the topic loci, but I want to believe I'm going to show you something here which will help you get loci. Prerequisite information that you need are the following. The prerequisite information that you need are the following. So look at the board and see what I'm drawing here. I've drawn a triangle ABC. There are 5 types of loci. Someone is going to ask you to bisect a line. Bisect line BC. We know how to bisect line BC using a ruler and a pair of compasses. You can bisect that line. Number 2, someone is going to ask you to bisect an angle. We can bisect this angle at B. All of us are aware of that. That is locus number 2. Some of us are going to be asked, draw a circle. Center A. Radius maybe 2 centimeters. If you're going to draw a circle, center A, radius 2 centimeters, you just measure the 2 centimeters using a protractor or a ruler, then come at A, you draw your circle very comfortably. Locus number 3. Number 4, we are talking about drawing parallel lines. If I'm told to draw a line parallel to BC, and it's 2 centimeters away, that is a locus. And then number 5, we are going to ask ourselves the angle properties of a circle. Angle properties of a circle. Here, I'm going to mention something here. If I have an angle at the circumference, subtended by a chord, let's call it PQ, then it means the angle at the center is related to the angle at the circumference. If this is 30, then this will be 60 degrees. So someone is going to tell you, draw the locus of a point R such that angle PRQ is equal to 30 degrees. So this is the arc that I'm going to draw. This is the arc that someone is asking you to draw. It means you must have an information or knowledge about how to draw or the angle properties of a circle. So in this case, you only need to know the angle which you need to draw at this particular point, this one, so that you get the center, and then you draw your arc. That arc becomes the locus that is required. So now that I've said this is the loci, what is it that is now making this to be a little bit difficult? What makes this difficult is, some people are still online here. All right, so if someone wants you to bisect a line, the locus language is not bisect line AB or bisect line BC. The statement would be, there are 2 things. If you were to bisect line BC, someone will say, construct the locus of a point, let's call it T. Construct the locus of point T such that point T is equidistant from B and C. That is one statement. The interpretation of that means just bisect line BC. Construct the locus T such that it is equidistant from B and C. Alternatively, someone can ask you, construct the locus T such that line BT is equals to TC. The length B to T is equal to the length T to C. Those 2 statements will mean that you draw that. That's all. We can now incorporate what is called inequalities. Now we are talking about a region. If we are constructing that loci, then someone is saying region R or region T is closer to B than C. If it is closer to B than C, it means that you must check the midpoint. This is now the boundary. So from this boundary, it means it is equidistant. So if it is closer to B than C, then we move from the boundary towards B, meaning this region is the one that will be the locus that is required. If you are to bisect an angle, let's talk about angle B. Then the statement someone is going to give you in loci would be, construct the locus of a point, let's call it T, such that point T is equidistant from line AB and line BC. Equidistant from AB and line BC. So if it is equidistant, it means the angle there will be the same. So you just bisect the line. Equidistant from a line and another line, meaning we bisect the angle between the two lines. Alternatively, construct the locus T such that angle ADT is equal to angle CBT. ABT, which is this one, is equals to CBT, which is this one here. That is the same thing as getting the bisector of an angle. If someone wants you to draw a circle with A as the center, radius 2 centimeters, that is still a locus. Construct the locus of a point R, 2 centimeters from point A. So if it is 2 centimeters from point A, it means we're talking about the radius. 2 centimeters given is the radius from point A. That is a stagnant or a stationary point. So we will be drawing a circle center A. The radius there will be 2 centimeters. Then you label the locus there. If it is R, you write letter R on that arc, or rather on the circumference of the circle. Number 4, parallel lines. Someone wants us to draw a line parallel. Let me now write this. We still have our triangle here. This is ABC. Someone wants us to draw a line parallel to BC, maybe 2 centimeters away. What are we supposed to see? Construct the locus of a point P, such that P is 2 centimeters from line BC. If you can check what we did for the circle, we said the circle was 2 centimeters from point A. Here we want to draw the locus 2 centimeters from line BC. So if it is 2 centimeters from line BC, then the interpretation will be draw a line parallel to line BC and 2 centimeters away. Then we come to the final one. Now that is the constant angle locus. From this diagram, you can see if you wanted to draw this as your locus, you needed the center of the circle and the radius. And this one we'll get by getting these angles at the center there. That is not very visible. I think that is okay now. Let me just draw it somewhere at the center. If this is what I wanted to draw this arc. This is the chord that is given, PQ. The angle at the circumference, the angle here, the angle subtended by this chord from here up to the other end Q will always be constant, so it's the same. So if this angle here is 30, then for us to draw this arc, I need the center. To get that center, I need to know what is the angle at the center, which will be twice that at the circumference to be 60. So this will be 60 again, this will be 60. To make our work easy, something is going to be given to us, and what will be given to us will be the chord. So I have chord PQ. Then you're told construct the locus such that angle PRQ is 30 degrees. You simply draw an arc after identifying your center. How do I identify the center? I want to give a formula here which will help us identify the center. I need to know the angle at the base here. To get that angle as the base, just write the angle is equals to 90 minus theta. Theta here is our constant angle. If the locus, constant angle locus will be PRQ is 30, then it is 90 minus 30. 90 minus 30 means we draw 60. Construct 60 here, construct 60 here, where the meet is the center. Then we draw our arc there. That becomes our locus arc. If the constant angle here is 60, then we'll take 90 minus 60, meaning now instead of constructing 60 here, we'll construct 30, where the meet is the center. Draw your arc. This arc you're drawing must begin from point P strictly and end at point Q. Let it not go below. If the constant angle here is 90, 90 now means that there is a chord specifically that always subtends an angle of 90 degrees at the circumference. That chord is called the diameter. So if the constant angle is 90, then it simply means that the chord given there is the diameter. So what do? I don't need to construct angle 0, because if you take 90 minus 90, you get 0. You can't construct the 0. So what we will interpret that to mean, this is the diameter, bisect, get the midpoint. Then you draw your circle. That becomes this, the locus. If the constant angle is 120, maybe now it's greater, then just subtract 90 minus 120 to give us negative 30. So negative 30 here, this is what we'll do. The same thing as we've been doing. Construct your 30 here, your 30 here. Where they meet is the center. Take your compass, locate it up to P or Q. Then you draw your arc, this time on the other side, because it was negative 30. So you draw your arc on the lower side. That becomes the locus. And as I've said, I'm repeating, make sure you label on that arc as that is your locus. I want to believe that is enough information which can help us comfortably maneuver the loci bit. Someone will ask a question if necessary. Let's move on to special tropical areas. The special tropical areas include areas like statistics, they are listed there, probability, quadratic equations, variation, and angles, circles, chords, and tangents. Those are special tropical areas which we must look at. If I can mention something briefly on statistics, then we have 3 types of data. Let me just mention the 3 types of data so that we know what to deal with. Number 1, maybe I can talk about, I have some shoe sizes of some 6 students. One is 38, 40, 41, 32, 45, 1, 2, 3, 4, 5, and then maybe 44. Another type of data, we can have the shoe sizes 38, 39, 40, 41, 42, 43. And then here we've been told that we have some frequency in this case. The frequency here may be 1, 3, 4, 6, 8, and maybe 5. The last type of data that we can see is where we have put them in classes. So I have maybe 10 to 20, 20 to 30, 30 to 40, 40 to 50, etc. Assuming those ones are, let's call them X, and then we have 3, 4, 8, 10. Data number 1, number 2, number 3. What you need to do as a candidate, be in a position to know how to calculate in paper 2 measures of dispersion using this. What are the measures of dispersion? I'm going to explain that. We'll have something like, this time we have quartiles. You can calculate what is called standard deviations. Before that, we have the variance. We have the standard deviation. We have the mean absolute deviation. We have the deciles. We have the percentiles. What else do we have? Variance, standard deviation, we have that. We can also get the mean, but now this time we are using assumed mean. So my interest is, if you want to be keen, because definitely you will find one of this data in your KCC exam. I don't know which one, but one of them will appear. Be in a position to calculate all these things when you're using this type of data, this one, this one. And these classes can be different. We can use inequality when it is like this. Instead of saying 10 to 20, we can say 10 less than or equals to x less than 20. We can say 20 less than or equals to x less than 30. we'll say 30 less than or equals to x less than 40, 40 less than or equals to x less than 50. So this is the same thing. There's no difference here. In other words, if this value is the same as this, then that becomes the boundary. At the same time, it is the limit. So 20 is the upper boundary of the first class. 20 is the lower boundary of the next class. 20 is the upper limit. At the same time, it is the lower limit for the next class. We can as well have like one that I indicated initially. That can be maybe 10 to 19. We can have 20 to 29, 30 to 39. We must know how to maneuver when the classes are represented in those different ways. So with that, we are supposed to be in a position to calculate all that is there. We are on the right track. When you talk about probability, I know it's a wide area. Know how to represent your probability values. Probability has got a range. So anytime you're answering a question on probability, your answer cannot be anything less than 0 or anything greater than 1. So the range of your answer should be between 0 and 1. You can represent these probability values using 3 means. 1, you can use percentages, you can use a decimal, or you can use a fraction. For the fractions, you can choose to simplify or not simplify. No one will penalize you for not simplifying an answer if you're dealing with the probability question. If you have a fraction like 20 over 30, 20 over 30 when simplified is 2 over 3. If you don't simplify it, you'll still get an answer. But common practice in most cases, if you don't simplify your fraction as an answer, you'll be penalized. So I'd rather you simplify all your fractions. When we go to probability, when we are still at probability, we can talk about the tree diagram. The easiest way to represent information is on a tree diagram. And here it requires your understanding. Your tree diagram will have a number of branches. How many branches depends on what we are going to do. For example, if in a class I have boys and a girl, boys and girls, and then a student is picked at random. So the student are going to pick the results. The possible results are 2. So my branches of that tree will be 2. If I had 3 different categories of things, maybe I have blue pens, red pens, and green pens put in one box, and I want to pick one, it means the options there are 3. So I can either pick a blue, green, or a red pen from that pack. Therefore, if I'm representing that information using a tree diagram, then my branches are supposed to be 3. This other area called quadratic equation, very important. I want to assume that every one of us know how to solve quadratic equations. You will be asked to solve a particular quadratic equation, and you will be restricted on a formula to be used. Mostly, you will be told using completing square method, solve this quadratic equation. So know how to solve quadratic equations using all the applicable or all the formulas that are there. Don't leave even one. If you're talking about when given the roots of a quadratic equation, how do we solve it? You know how to do that. If not, maybe I can explain that bit. If I'm supposed to solve given the roots of a quadratic equation, roots means a solution. Someone says there is a quadratic equation whose roots are 2 and maybe -1. Tell us what is the equation of that. This is very simple. Just reorganize this equation and say this is x minus 2 is equals to 0. Of course, if you bring 2 onto the left, we'll have x minus 2 is equals to 0. Here we'll have x plus 1 is equals to 0. So this one is 0 and this one is also 0, meaning if I multiply the 2 of them, I will get 0. So in the process of now opening these brackets, we'll have x squared, then this will be x minus 2x, which is just minus x minus 2 is equals to 0. So this becomes the quadratic equation whose roots have been given. If the roots are given as a fraction, maybe 2 over 3, you do the same thing, but you can remove that fraction by just saying 3x is equals to 2, so that you have 3x minus 2 is 0. And then you work it out comfortably with that. Variation, I will not delve so much onto that, but it is an area under that category that you need to remember. You can get it, or you will get it in KCSE. We have another area here that we're calling circles, chords, and tangents. And then we have angle properties of a circle, very important. A candidate must know the angle properties of a circle, all of them. Sometimes you're given a diagram and you're told, giving reasons, state the following angles. The best approach would be, you are not going to remember those properties one after another to get a particular angle. So go to the diagram, use your pencil, write on that diagram with all the information that you have, calculate those angles. Once you're done with the ones that you can comfortably calculate, then go back and now check what are the questions that have been asked. Check if you have gotten some angles, just list them down. If there is one that has not been given, then that would be fine. Then on setting reasons, you can remember a bit of the reasons. There are so many reasons that can lead to one particular angle. So state any one relevant reason on every space for that particular angle. Don't repeat the same reason for all the angles that are there. Someone will penalize you for that and say you are not serious. Let's move on to the next area. And I think that is calculus. I've mentioned all that. Calculus and area estimation. That is what I should be talking about now, so that we come to a close. Yes. Calculus and area estimation, you are told something about in paper 1, that calculus is in paper 1. Which part of calculus is in paper 1? Mostly it is differentiation and its applications. In paper 2, we are a little bit flexible to talk about integration. Integration mostly will come in paper 2. So what we need to do, I want to advise that if you are revising for an exam where All right, I want to get back to our board. Not share. Don't share. Don't share. Sorry. Because so if someone gives us something like A or X over Y, and wants us to get the maximum value for X plus Y, and you want to get the maximum or minimum value or X minus Y or X times Y, we should be in a position to work out this comfortably so that we know that if we are talking about maximum of a fraction, I'll take the maximum of the numerator divided by the minimum of the denominator. These values can be given either as a measurement or they can be given as a range. For example, someone says that X ranges between 5 and 10, and then Y ranges between, let's say, 2 and 4. So how do we get the maximum of X over Y? Maximum of X over Y will be the maximum of X divided by the minimum of Y. If I look at X is ranging from 5 to 10, meaning the maximum of X is 10, the minimum of X is that. So for the maximum value here, I'll get 10 over the minimum of Y, which is 2, and that will be 5. If I want to get the minimum of this, then I'll take the minimum of the numerator divided by the maximum of the denominator. That is 5 divided by 4. If I'm having now a sum, the sum here will be simple. If I want the maximum, then I'll take the maximum of both of them. Minimum, the same. Product here again, if I want the maximum, I'll get the maximum of both of them. Multiply together. If I want the minimum, I'll do the same to get that. If it is subtraction, then I'll go back to borrow this. Maximum here will be maximum X minus minimum Y. Minimum here will be minimum X minus the maximum value of Y. So that is something that we should be in a position to work out or to get whenever we are dealing with error. Know very well that we have something called absolute error, relative error. How do we get absolute error? How do we get the relative error? Let me take this example quickly. Someone says, calculate the relative error in this. 3 plus 6 minus 4. Let's say 4.5. What is the relative error in that? The relative error in this we can get by working out the maximum value minus minimum value divided by the actual value. No, maximum minus minimum divided by 2 to give us the absolute error. Once we have the absolute error, we will now take relative error to be this absolute error divided by the actual value. But you see, if we have this, we can get the relative error directly by simply saying here, the relative error is equals to the sum of the relative errors here, or rather the sum of the absolute error here, which will be the absolute error in 3 is 0.5, in 6 is 0.5 again, in 4.5 is 0.05. That is the sum of the relative errors. Then I divide by the actual thing here, which will be 3 plus 6 minus 4.5. That will give you the relative error. So I can avoid this long approach to get that. If it is given as 3 times 4.5, what is the relative error in this case? Still, I can go to the maximum minus minimum over 2 to get the absolute, or in this case, because it is a product, I can say my relative error is the sum of the relative errors of this, which is 0.5 over 3 plus 0.05 over 4.5. That will give us the relative error in that case. Of course, after getting the relative error, you can work out the percentage error by dealing with the percent, or rather multiply by the relative error by 100%. That will be okay. Let's go to the next case where we have that is SADS. We need to know how to rationalize SADS as indicated there. Rationalizing SADS simply means you remove the root signs from the denominator. And once you do that, you will be good to go. So rationalize the denominator, simplify SADs, application of SADs in trigonometry. So you must know the special angles, which we can write their values without using. Let me just give this example so that we can see. If I have maybe sine 30 minus cos 420 over tan 135. This is application of SADs in trigonometry. So we must know how to write these angles which are greater than 360 or greater than 90. How do we get the acute equivalence? 420, 30 is just fine. 420 there, we will have to bring the unit circle and ask ourselves. 420 will be, I'm moving 360, add 60, we'll move at 420, meaning an equivalent of 420 is 60 degrees, and it is found in the first quadrant. Being found in the first quadrant, you must remember the conditions for all the ratios in each of the 4 quadrants. In the first quadrant, all the ratios are positive. So it means if 420 is found in the first quadrant, then cosine of 420 is the same as the cosine of 60. 135, you can see 135 is found in the second quadrant here. So if it is the second quadrant, what is the acute equivalent? 135 subtract from 180 so that you get this, that will give you 45. So this angle here will be 45. So 135 is the same as 45, but it is in the second quadrant, meaning this is going to be negative. So what do? We will rewrite the story, sine 30 minus cos 60. We have agreed 60 and 420 are in the same quadrant, so all the values are positive, but this one here is going to be tangent of 45, negative tan of 45. Once this is done, remember the special ways of calculating this or getting these trigonometric ratios. The triangles we always use. Some calculators will give you direct values, but if they say without using a calculator, then you must know what you're supposed to do. So what do we do in this case? If it is 60, here will be 30. I will have here as 1, 2, here with 3. So you can get sine 30. Sine 30 is 1 over 2. So this will be 1 over 2 minus cos 60. Cos 60 is 1 over 2 again, because that will not make some more sense. Let's use sine 60, sine 420. So if it is sine 60 now will be root 3 over 2. So we'll have root 3 divided by 2. Then divide this by negative tan 45. Tan 45 is just 1. So negative 1 is just that. So this value here will be a half minus root 3 over 2, which we can simplify and write as a single fraction as 2, 1 minus root 3 as your final answer. So it is important that we are in a position to simplify SADs according to the instructions that are given. Whether it is on application of trigonometry or we've been given direct SADs, if the angles are not, or rather the values are not simplified, then you must be able to simplify them accordingly. Trigonometric equations, like the one that is given on the screen there, just check it. That trigonometric equation, some things can be asked of us. Y is equals to sine bx plus c. So you must know, if I have an equation, how do I tell this is the amplitude? How do I tell this is the period? How do I tell this is the frequency or phase angle? So you must be in a position to do that. So in that case, you can see y is equals to, we can put a letter a before the sign. So if it is y is equals to a sine bx plus c, that would mean that a becomes our amplitude. Amplitude, of course, is the maximum point that the graph will reach. B, which is the coefficient of x there, will help us get the period. So to get the period, we'll take 360 divided by b, and then c will be the phase angle. If that value of c is negative, let's say it's negative 40, then don't state your c as a negative. C is a scalar quantity, so it cannot be a negative. The equations involving trigonometry can also be sorted out in that case. Quadratic equations I've talked about, perfect square, completing square method, finding this equation when you're given the roots, or solving simultaneous equations leading to that. Equation of a circle, 2 things. we can be asked to find an equation of a circle given the center and the radius. So you must know the general equation and you must know the procedure of how to find the equation of a circle given the center and the radius. And number two, if given the equation of a circle, can you be able to identify the center or come up with the center and the radius? That will call for that knowledge on completing the square.
If you have a question, Charlene? Hello? Hello? Yeah. You can ask the question. Shireen?
Sorry to take you back, but there's a question on longitude.
On?
I have a question on longitude.
Go ahead.
The positions of two towns, A and C, are 61 degrees north, 140 degrees east, and 61 degrees north, 40 degrees west for town C.
All right.
Calculate the shortest distance between point A and C in kilometers.
The most important thing, if you're talking about the shortest distance, you must check. Now, in this case, look at the longitudinal difference. What is it?
40. Okay, longitudinal difference is 180 degrees.
Very good. So if the longitudinal difference is 180 degrees, then it means for us to move from point A to C directly or using the shortest route, then we must go through the North Pole, right?
Yes.
So moving through the North Pole means we are going to have, let me have this point. This is point A, this is point C. So I'm moving through the North Pole, meaning I'll do that from the center. Are you seeing what I've drawn there?
I'm not.
You're not seeing?
Can you turn your camera on?
Can you see it now?
Not.
Not yet. Are you seeing it? Sherin? Hello?
Yes, you are on mic, Shireen.
Sherin?
Yes.
Can you see the board now?
I can't.
Really? Remember?
Your camera is not on. Oh, okay. I can now see.
You can see what I've done on the board here?
Yes.
You're right. No, that's good. So we were saying that if you're moving from point A to C through the North Pole, the shortest distance, we have identified that the longitudinal difference is 180. If it is 180, then the shortest distance will be through the North Pole. So the only thing you need to do, this is a circle, so we need to get the length of that arc. That arc we'll get if we are able to identify this angle here. The 2 points are lying on latitude 61 degrees. So this angle here is what is 61. This is 61. Meaning if this is a straight line, the angle remaining here will be 180 minus 120. That's fine.
Yes.
What is 180 minus 122?
58.
That is 58 degrees. So if we now want to get this distance in kilometers, remember the formula? Distance is equals to theta over 360 times 2 pi r. So this theta is the 58 we are using. Pi and r will be given. So that will be the shortest distance. If we wanted the same distance in nautical miles, we'll use that 58 times 60. Then we are good to go. But now, what I want you to do is just check if the longitudinal difference is 180. Then the angle you need to use is just 180 minus 2 times the latitude. The latitude you have to multiply by 2 for what I've demonstrated there, so that you're able to get the angle in between that. Is that clear now?
Kindly pardon the last step.
I've said, if you've been given 2 points like we have, and you realize that the longitudinal difference is 180, then our shortest distance will be through the North Pole. So I've drawn that here. What we need to do here now, because this is an arc of a circle, we will need to get the length subtended at the center. That length is theta. How do I get it? I need to know this angle besides here, which are determined by the latitude at A. Latitude at A is 61. The latitude at B is also 61, meaning 61 plus 61 is what we got as 122. So 180 minus 122 will give us the angle at the center of the circle. Our formula remains the same, theta over 360 times 2 pi r, where our theta is simply, that is what I've written here, 180 times 2 times latitude. Latitude, where the 2 points are lying, is 61. 2 times 61 is 122. 180 minus 122 to give us 58. Is that fine, Shari, now?
It is.
Thank you. Anybody with another question? Nema? Nema, you can ask a question.
I was asking on the question under compound interest, when you're given your value of n as a decimal point, could you kindly repeat the last part for simple interest?
Where I involve the simple interest, huh?
Yeah.
So we say that the compound interest formula, this one, raised to n, we will only use this when we are doing compounding of money. The value of n must always be an integer. So let's take an example that our deposit was 20,000, and that money is staying in the bank for 2.5 years. So deposit is 20,000, then time is 2.5 years. 2.5 years. Then the interest rate, let's say, is even 18% per annum. Are we there? Nema? Nema? Nema, you're on. Are you with me? Nema? Nema umepotea. Iko sawa? Neema,
Oh, yeah.
you getting me now?
Yes.
So if this is what we have, then I say that so long as we are doing the compounding, we cannot make this substitution and say 20,000 into 1 plus R 18 over 100 raised to 2.5. Our n cannot be a decimal number. So in that case, what we'll do, the reason why it cannot be a decimal number, because we are saying compounding is done yearly. That means after a whole year is when we can get the compound interest, right? So because this money is staying there for 2.5 years, we have to work it out for 2 years. So whatever we get here, this I think will be, if you get your calculator, let's assume we're getting 25,000. Okay? So this 25,000 will be the amount in the account after 2 years, but the money has stayed there for 2.5 years. What then do we do to get the amount after 2.5 years? Because we're remaining with a half a year, we can't compound that money. Because the compounding was being done per year, but a half a year is not a complete interest period. So we will be working out interest on this amount of the 6 months that are there. So this will be 25,000 times the rate. This time now we're going to divide this 18 by 12. Why? Because 18% was the rate per year. Now we are getting the simple interest in the 6 months. So we are taking it monthly. So that rate per year we divide by 12 to get the rate per month. Then now that will be 18 over 12 times, the time will be 6 months. You divide this by 100. That will give you the simple interest in this amount. So if we were asked to get the total amount of money in the account of 2.5 years, we will add this simple interest onto the 25,000 to give us the total amount of money at the end of 2.5 years. Is that clear, Neema? Neema? Neema, network yako si mzuri sana, but I hope I've answered your question correctly. Shireen, let me go to Michael first. Then you, Michael. Michael. Yes. I might just go back to Shireen. Shireen, you're on.
How do you use such line to calculate maximum profit in linear programming?
Such line. A such line, you must be given what is called an objective function. Now, let me give you an example. If we have profit is equal to 2,000 x plus maybe 1,000 y. That statement that gives you the profit is called the objective function. Are you together?
Yes.
So if I want to assume that I have plotted my values on the x and y axis, let's say I have this. This is what I had. Maybe this is the boundary area that I have. This is my region. This is my region. And then I've been given that objective function. I want to draw what is called a search line. Anytime the objective function is given, you must make sure that you draw a search line. And this search line is a very simple thing to do. This is an equation of a straight line. The best way to do it, just get the gradient of this line. Remember, if I give you a line y, or rather 3 is equals to 4x plus 6y. How do you get the gradient? You just say negative 4 over 6. That's right. Shireen? Shireen? Shireen, are you getting me?
Yes.
If I give you this equation, this would be the gradient, right?
Yes.
So in this case, what would be our gradient? Negative 2,000 divided by 1,000, right? Just take the coefficient of x, you divide by the coefficient of y. So that will give us the gradient. So once I have this, then depending on the values that you have on your scale, you can have equivalent fractions there. This can be 2,000 over 1,000, 20 over 10, 2 over 10, 200 over 100. So that if we are drawing a such line, gradient is always changing. This is the vertical displacement. So you move vertically either 2,000, depending on the values here. Let us assume we have 100. This is 100, 200, 300, 400. Say maybe this side, 100, 200, 300, 400. So this fraction can be 200 over 100, of course negative, or it can be 20 over 10. So I'm saying that depends on the scale that we have used to draw our graph. If that is the case, vertical displacement 200. So I'll come at 200 here. Horizontal displacement 100, that will be here. That is the line that you draw, and you label it. That is the search line. So using your search line with the ruler and the set square, move it into that region to get the maximum point and the minimum point. The maximum will be the last. When this one moves into the region, and the set square will be the line. The edge of the set square will be treated as the line that we're dealing with. It is called a search line because it's touching that maximum point or minimum point. So when you move it inside, the last point it will touch before it leaves that region R, that point gives you the maximum point. So if you find it, for example, here, maybe 400, 300, you simply go and substitute these values of x and y to get the profit. If you wanted the minimum, then it means the first point that this line is touching inside that region, the first coordinate, if it is touching a point like maybe 150, let's say 200, then these are the values we will substitute in your objective function to get the minimum point. Sharon, is that correct?
Yes, thank you.
All right. Let's have Kevin. Kevin?
Yes.
Yes, Kevin.
Okay, I had a question. I need you to help me differentiate between these two. We have interest compounded per annum quarterly at the rate 20% and interest compounded per quarterly.
Come again. Interest compounded.
We have interest compounded at the rate of 20% per annum quarterly, and we have interest compounded quarterly.
Interest compounded per annum 20% quarterly.
Yes, and we have interest compounded quarterly.
All right. I think there is a mix-up in those two statements. The expectation that I have, the rate that you're going to be given will be the interest is 20% per annum. If the rate is interest, the rate of interest is 20% per annum and it is compounded quarterly, right? Kevin? Kevin, are we together? Yeah,
Yes, Kevin, you're on mic.
Okay, so my question was,
yes,
we have, let's say like 50,000 shillings compounded at the rate of 20% quarterly per annum. And then we have, let's say the 50,000 compounded at the rate of 20% quarterly.
No, that is a mix-up. We cannot tell you it compounded quarterly per annum. Huh? That is a mix-up of the statement. So the rate can be given per annum. If it is 20% per annum, then we are told the compounding is now done quarterly. But we cannot compound it 20% per annum quarterly. That is a confusion. It's a mix-up, right?
Yes.
So what we should have, it is the rate is 20% per annum compounded quarterly. So if it is per annum compounded quarterly, then you must know the 20% is per annum. But if it is compounded quarterly, you divide that by 4 to get the rate for the interest period of a quarter of a year. So we cannot be told compounded per annum quarterly. That is a mix-up of the two statements. I hope that is fine now.
Okay.
Otieno Martin?
So don't require this G.
Pardon?
I have two questions.
Yes, Martin.
One is on the tax rate. So there is a table. You are given a table of monthly taxable pay and the tax percentage rate. But yeah, the percentage.
Yes.
On the column of monthly taxable pay,
Yes.
we have 9,680. Then at the tax rate, we have 10. Another one, we have 9,681. And we have to 18,800.
Rate 15.
Yes. Another one is 18,801 to 27,920.
Rate 20.
Yes.
Go on.
Then we have 7,921. Then we the to 37,040.
Rate 25.
5 years.
Then above.
Then 37,041 and above. Rate is 30.
Yes.
So I've been having a problem of solving that. It has been disturbing me a lot. And now the question was that no, I've not finished it. Then they say that year Mary paid the basic salary. The basic salary is of 22,600. Then the total monthly taxable allowance amounted to Kenya shillings 15,220. And then we have when she was entitled to a monthly relief of 162 shillings.
1062 or 162?
162, not 1062.
Okay.
It's 1062.
Huh?
It is 162.
So go on.
Then every month of the following
Go on.
were made 20
Repeat that.
shillings.
Repeat that every month.
Every month the following deductions were made.
Yes. You can lump them together. You don't need to read.
Okay. NHF we have 320. Union dues we have 200. Cooperative shares we have 7,500. Yeah, then they tell you to calculate Mary's taxable income. The taxable income now, a taxable income. Then another question they say
Taxable income, you're comfortable with that?
No, I have the problem in that section, the whole of it. So
that is why I want us to go. I want us to go step by step. The first question is calculate the taxable income.
Yes.
We agreed that taxable income is this case. We have not been told whether he was housed or not, right?
Yes.
So that means the taxable income here is just the basic salary plus allowances. So here you take your 22,600. Add to all those allowances, which is adding up to 15,220. That's fine.
Sorry?
Basic salary plus the allowances. 22,600 add 15,220. That gives you 37,820, right?
Yes.
So 37,820 is our taxable income. And I say, if you are to work out that question, you make sure your taxable income is correct. So 37,820 becomes our taxable income. That is the basic salary plus the allowances. What was the next one?
We have the monthly net tax.
Net tax. Do you know how to calculate the tax from this table? Using the table to calculate tax now that we have the taxable income.
We work with the table. Like that one of 1 to 9,680 times 10.
So it is 9,000. So you don't say 1, 2. So the first amount that we're taxing is 9,680 times 10. This 10 is 10%. Okay?
Yes.
Right?
Yeah.
10% is 10 over 100. Then it gives you 968. That is the first amount that we have been taxed. So we have to tax everything up to here. So the next one, take 18,800 minus 9680. What is your calculator giving you?
It gives me 9,120.
9,120. This one now we are taxing at 15. So that is 15 over 100. Get me what that one gives us?
It gives 1,368.
Correct. So far we have taxed in the two bracket meanings we have taxed 18,800. But we are objected to do that, right?
Yes.
So we go to the next slab. Take 27,920 minus 18,800.
Minus 1,800.
Yes, this minus this. We are getting the amount in the slabs. That's the easiest way to do it. So.
Yes.
The first one we got, this one we used 9680. The second one is this minus this, which is 9120. The third one is this minus this. What is it giving us?
9,120.
Again, by 20%, what does it give us?
By 20% over 100, it gives 1,820.
So we have taxed up to this point. Now we have how much money we have taxed? 27,920, right?
Yes.
So we can still go on because we still have more to tax. So we come into this, right?
Yes.
So this one subtract 37,040 minus 27,920.
9,120.
9,120 times now 25%. Give us what?
25 divided by 100. It gives us 2,280.
Correct. So far we have taxed this, and this is what we have, right?
Yes.
So everything that is left now let up. Is that okay?
Yes.
So now that we have this and we have taxed this, so take 37,820, subtract 37,040.
That's 7,820
minus 37,040.
That is 780.
780. Now we are taxing at 30%. What do we get?
Times 30 divided by 100. That is 234.
234. So we have finished our taxation. Are we there now? Kelvin? Are we okay now? Hello? Kelvin? Kelvin? You're lost. I hope we were moving well. But I hope you're seeing what we have done here. I can't hear you. Check for me that young man. I don't know. I'm going to Kelvin. Huh?
I'm back.
You're back.
Yes, I think it's a matter of
Network yako ni mbaya, right?
yeah, maybe.
It's fine. So this amount that we have here, you add them together, okay?
We add them all.
Yes, 968. Unaona tukipata ya kwanza ni 968, huh?
Yes.
Plus 1368.
Yes.
Plus 1820.
1820.
Plus 2280. Plus 234. What do you get?
We get 6,670.
6,670 is what we are calling gross tax.
Gross tax.
Yes, that is the gross tax. That is the total tax, total amount that this person has been charged. Okay?
Yes.
So the question was asking?
They want monthly net tax.
So if this is gross tax, then we ask relief. So tulikuwa na relief hapa.
Relief was there, yes.
Yes, so subtract that relief from this 6670. Whatever you remain with is the net tax. That is the payee. That is the amount the person pays as the tax.
Which is 6,508.
So net tax is 6,000?
6,508.
Yes, that's it.
Then the next one was her net salary.
Net salary, we agreed. Net salary is the total income. Total income is basic salary plus allowances minus total deductions, okay?
Yes.
So total income, you add this and this, total deduction, your net tax is the first one. That's fine.
Yes. You say we add 22,600.
Plus the allowances, 15,220. That is your total income.
Yes.
Then now you check what is the total deduction because you want to get the difference between the two, right?
Yeah.
So total income is that, total deduction. Deduction number one is your net tax, which we have calculated and gotten 6,508. Is that okay?
Yes.
Then there are those deductions that you are reading for me. I told you you can leave them, but they were specified deductions. You remember what you were reading? NHIF, hizo zingine?
Yes. Yes.
So then you add them to this net tax. All of them you add to this one. Whatever you get gives you the total deduction. Thereafter, you now take total income minus total deduction to give you the net tax, net salary, sorry. Is that okay now?
Yes.
All right. We stop there. I get another question from someone.
I said I had two questions.
I asked the other one quickly so that we can finish.
The other one was it was a matter of complete the table. That one is the equation for the equation.
Question of?
Whereby we had y is equals to x squared plus 3x plus 1 for -5.
-5 to?
-5 equal or less than x
less than or equals to?
2.
So what is the question?
They're asking. They want us to put it on the
Fill the table.
On a graph.
Yes, see, there is a place they're asking you to fill the table.
Yes, they're asking us to fill the table.
Are you in a position to do that?
Yes, I can do it.
Very good. So once you fill the table, then those points or values you're getting of the table will give you the coordinates.
Yes.
Which you will plot. And if you plot, you will get a curve, quadratic. If you remember the shape that I showed you initially, for a quadratic graph, then you can see what it is, huh?
Yeah.
Yes.
Thank you very much.
All right. Fiona?
I have a question.
Yes, Fiona.
Give the equation of the normal to the curve. Y is equals to 4x cubed plus 2x plus 1 at the coordinates 1, 4.
1, 4.
In the form y is equals to mx plus c.
That's okay. So you remember an equation of a normal is just a straight line, right?
Yes.
If you want to get an equation of a straight line, you need two things. You will need the gradient and a point. Is that okay?
Yes.
So if you have this equation, are you seeing the board?
Yes.
So this being a cubic curve, maybe assume it's looking like that. So we want to get the equation at this point, the tangent, the equation of the tangent And then the normal is now the perpendicular of the tangent. That is what they want. But you see, if we have an equation of a curve and we want to get the gradient of the tangent, then there must be a formula. If you get to paper 1, when you talked about differentiation, there is a reason we differentiate, okay?
Yes.
Whenever we differentiate, we come up with what is called the derived function or the gradient function. So here, dy dx, what will it be? Differentiate with me. You know how to differentiate?
Yes.
Yeah, so this one is 3 times 4 to give you 12. Then x, you reduce the power by 1. Huh?
Yes.
It is 12x squared. Then if you differentiate this, you get 2. So this out.
2. Yes.
So this one is called the gradient function. Gradient function is the formula for finding the gradient of the tangent. So the tangent is this line that we are drawing here. But the question is asking us the gradient of the normal. A normal line is a perpendicular to the tangent, okay?
Yes.
So if we can get the gradient of the tangent, this is the formula. So if this is the formula, what is the value of this gradient when x is 1 at this point? We substitute 1 here, so
Yes.
that will be 12 times 1 squared, which is 12 plus 2, and that will be 14. So m is equals to 14. Tuko sawa?
Yes.
And that is the gradient of
The
tangent.
gradient of yes.
Yeah, so we want the gradient of the normal. So two lines with which are perpendicular. Do you know how the gradient relates?
Yes. M1
Yeah, so
plus M2 is equals to negative
this will be negative
1.
negative 1 over 14.
1 over 14. Yes.
So
Yes.
now that I have negative, this is the gradient I'm going to use, and the point already is given as 1, 4. So your work is now easy. Just say y minus 4 over x minus 1 is equals to negative 1 over 14. So
Yes.
from here now you can cross multiply 4 by this, 14 by that is 14y minus 56. 6 times 4 is 4 times 14 is 56, right?
Yes.
Is equals to negative x plus 1. That's fine.
Yes.
And take 14y is equals to negative x plus 57 now. So that's fine.
Yes.
Divide through by 14, so you remain with y is equals to negative x, which is now negative 1 over 14, x plus 57 over 14. Are you seeing that?
Yes.
This is now the equation of the normal that you are asking. So the most
Can you
important thing, you must know how to get the gradient of the normal and then the gradient of the tangent. Tuko sawa?
Yes.
All right, let's go back to Shireen. Shireen, welcome back. I hope that is the last question now.
Yes.
Go ahead.
The first term of an AP is negative 11.
The first term is negative 11.
The sum of the first 8 terms of A is 52.
Come again?
The first term of an AP is negative 11. The sum of the first 8 terms of A is 52.
Is 50?
52.
The sum of the first 8 terms is 52.
Find the Roman 1, find the common difference of the AP. Then Roman 2, given that the sum of the first n terms of the AP is greater than 920, find the least value of n.
So let's do the first one. We want to get this. Can do this one quickly. The sum of the first 8. You know the formula for getting the sum of n terms? Charlene?
Yes?
You know the formula? The one that I've written there?
Yes.
That is what we will substitute there. So if the sum is 52, so we'll say 52 is equals to n. N is 8. 8 over 2 is 4. Okay?
Yes.
Y 2 times a is negative 11. So 2 times negative 11 is negative 22. Plus n, which is 8. 8 minus 1, 7. Huh?
Yes.
7b. Are you seeing that?
Yes.
So in that case, we are able to get the value of B. Take your calculator, 52. Sharin? Sharin? Sharin?
Yes.
52 divided by 4?
Okay, D is equals to 5.
Very good. Done it. That part is the problem. The other part is the problem, Sharin. Sharin, your network.
I'm getting you.
All right. So read for me the second part. Given that the sum.
Given that the sum of the first n terms of the AP is greater than 920.
Greater than 920.
Find the least value of n.
So are you seeing what I've written here?
Yes.
So how do we get the sum of n terms? N over 2 into 2a. So 2a itakuwa nini? That's what we have. This is the expression for the sum of n terms, and this is what is greater than 920. So substitute here.
I'm not able to get you.
Are you seeing what the board? Sharon?
Yes.
Are you seeing the board?
Yes.
Are you seeing what I've written here? This is the formula
Yes.
for getting the sum of n terms, right? So that is the formula.
Yes.
Oh, yeah. So that sum is greater than 920. That's what we have written. So we want to solve this. That is what we need to solve. So how do we solve it? N over 2, 2a, 2 times that is negative 22. N at n minus 1 times 5. Greater than 920.
Yes.
So here I can multiply 2 by 2. This side by 2. What do we have here? N into negative 22 plus 5n minus 5 greater than 920 times 2?
1840.
So,
yes. Yes.
I open the brackets. This and this will give us negative 27. So 5n squared minus 27. I think that one this side will be minus 1840. Greater than 0. Unaiona?
Yes.
Very good. This is quadratic equation, is it?
Yes.
You can solve it?
Yes, I can. Thank you.
So if you solve this, then you will get your value. Whatever you get here, let us assume we can do factorization. You have a formula, a calculator that can work with it. Let me see. Let me just work out that question. Sharin?
Yes.
Have you tried that equation?
Okay.
Let me work it out for you. You will work it out later. So,
yes.
Minus 27 minus 1840. So x1, if you use the square method, n will be 22.07 or negative 16. You getting that?
Yes.
So,
yes.
So if this is the case, then it means my left-hand side will be n minus 22.07 times n plus 16. That is the left-hand side. And this one is greater than 0. Back up on.
I'm not understanding why you're doing that.
What we are saying, I've solved the equation. If you solve this equation, you'll get 2 roots. I'm assuming here you use 0 is equals to 0.
Yes.
If you solve it, you'll get these two values. 22.07 and 16 point something, right?
Yes.
So if that is the case, then it means if you see n minus this is equals to 0.
Yes.
And this one ikikuja huku inakuwa n plus this is equals to 0. So we will have this minus this times this minus this is equals to 0. Make this equal to 0, we will get n
Yes.
minus 22.07 greater than 0. Sawa?
Yes.
So this means that n will be greater than 22.07. Mpaka hapo tuko sawa? Sharin?
Yes.
We
I'm
are
okay.
okay?
Yes.
So if n is greater than 22.07 and we were looking for the number of times, it cannot be a decimal, right? So which is the integer that is greater than 22.07? Which one?
$23.
Sharon?
$23.
23, very good. So n is equal to 23. That is the least value. That is the least value. I don't know whether you got something. You can follow it up.
What happens to the n plus 16?
N plus 16. If we do n plus 16, n equal to 0, greater than 0, what will happen here is n will be greater than negative 16. Are you seeing that?
Yes.
And you see n is supposed to be a number of times. Can it be negative, anything negative?
It can't.
So we ignored that, right?
Yeah.
Okay.
Thank you.
All right, welcome. We can take 2 questions. They're asking some. So we have Otieno and Joy. Otieno will ask the next question. Otieno. Otieno. Martin Otieno. Joy. Joy.
This is a section 1 question on trigonometry.
Section
1.
Right, go ahead.
Given that tan 67.5 degrees is equal to 1 plus square root of 2.
Speak up, be louder a bit.
Given that tan 67.5 degrees is equals to 1 plus square root of 2.
1 plus square root of 2.
Yes. Find tan 22.5 degrees without using mathematical table or a calculator, leaving your answer in its simplest form.
All right. Are you seeing what? Joy? Can you see the board? Hello? Joy? Joy? I'm not getting Joy. Joy? Joy?
Sorry, yes?
Unanipata vizuri?
Yeah.
Are you seeing the board?
Yes.
Are you seeing the triangle I've drawn?
Yes.
So let us take this angle to be 67.5. It means this one will be 22.5, right?
Yes.
So katoa inasema aje? Tan is equals to? Tan is equal to? So katoa, from so katoa?
Opposite adjacent.
Opposite of adjacent. So this one is 1.1 plus root 2 over 1. It's the same fraction, right?
Yes.
So that means the opposite here is 1 plus root 2. Adjacent is 1. Pythagoras theory can help us get the hypotenuse. But we don't need that because we need tan 22.5. Tan 22, again, opposite of adjacent. What is the opposite of 22.5?
1.
1, very good. So this will be Tan 22.5 is equals to 1. What is the adjacent?
1 plus square root of 2.
Very good. So you simplify this. How do you simplify this? This is a third, isn't it?
Yes, it is.
How do you simplify that? You rationalize the denominator. So what is the conjugate here? Are you seeing that?
Yes.
Can you do that up to the end now?
Yes, I can. Yes, I can.
It's all right. So that is how you're supposed to simplify your work. So the most important thing is, can you bring this story into a triangle and then employ the Sokotoa thing to help you work it out? So.
Yes.
All right. I'm not seeing any hand up. Seemingly we are done.
I have another question.
Do you have another question? Ask.
Vector R has a magnitude of 10.5 units and is parallel to vector Q, given that vector R has a magnitude of 10.5 units and is parallel to vector Q. Given that Q is equals to 3I minus J plus 1.5 K, find the position of the vector R.
So Q is 3I minus J plus
1.5 K.
Plus or minus?
Plus.
All right. So you want to get R, right?
Yes.
All right. Two vectors can only be parallel if one is a scalar multiple of the other. Is that okay?
Yes.
So Q can be given, you see the board?
Yes.
Q can be given as that minus that 1.5. That's fine.
Yes.
So R, because they are parallel, is this one times a constant. So we can say a constant K times 3 negative 1, 1.5. Which will be 3K negative K 1.5K.
Yes. Yes, sir.
So then what is the magnitude of R? You know how to get the magnitude?
Yes, I do.
Square root of what here? The square of that 3K.
9K squared.
What is the square root of negative K?
K squared.
K squared. Nasikia kuna mtu anakuambia hizo story. Unaona hii kitu vizuri?
Yes.
All right. What is the square of 1.5 K?
2.25.
K squared, right?
Sorry, yes.
All right. Add them together. 9 plus 1 plus 2.25 is 12.25 K squared, right?
Yes.
Square root of 12.5, 12.25?
3.5.
3.5 square root of K squared?
K.
Okay. And this one here is what we are having as the magnitude of vector R. So?
Yes.
So how is the magnitude of vector R related to the magnitude of the other one? One is a scalar multiple of the other, so?
Yes.
3.5K is equals to 10.5. So you can get K. So?
Yes.
Which
yes.
is? 10.5 divided by 3.5 is in 3.
Yes.
So if K is 3, then we can multiply here and get our vector R.
Okay. Thank you.
All right. You're welcome. So ladies and gentlemen, I think that marks the end of our session. I hope you have benefited in one way or another. And I want to wish you all the best. Thank you.
So thank you. I'll edit and also share the recordings on our WhatsApp group, so you can create time before opening the school so that you can follow. Thank you so much for your time. God bless you.